Hello, welcome again. In this session, I want us to look at under still a series of algebraic expressions, how to carry out factorization by grouping. Of course, in our previous sessions, we've looked at how or what factorization means, and we have different scenarios of algebraic expressions. Now, there are instances when factorizing an algebraic expression in the normal way, as we have seen previously, is not very possible. Remember, we said for us to factorize an algebraic expression, we look for a common term or common terms in that expression. But there are other instances, like we are going to look at in a short while, where it is not possible at the face of it to see like terms or common terms in an expression. For instance, let's look at a case like where we are asked to factorize. You could be asked to factorize an expression like nx minus 2n plus 3mx minus 6m. Now, previously, we learned that for us to factorize, we need to get a common factor. Like in this case, we have the four terms, and we are asked to get common factor. Now, there's no common factor for all these terms. Now, when that is not possible, again, we saw previously that there's no direct common factor. You look for like terms and then collect them together, the like terms, and then after which you look for common factor. Now, in this case, again, there are no like terms. So we don't have a common factor to all the terms, and there are also no like terms here. Yet we are asked to factorize. So it is still possible to factorize, but now by another method, and that is what we want to look at here, what we refer to as factorization by grouping. So what does this mean? As the name suggests, we have to first of all group the terms. And how do we group here? The grouping is done by pairing. In other words, having these terms into groups of 2. So you can either reorganize the terms or use them as they are. Like in this case, I want us to use them as they are. So here I would first of all take the first 2 terms and then have another group of the second 2 terms. After that, you look for common factor in those groups. So like in the first group, where we have nx minus 2n, the common factor is n. So I write my n and then introduce the bracket. Remember, factorization also means introduction of brackets. So x minus 2 because the n is there, not there. Then I come out to the next group, ask myself or ask what is the common term or what are the common terms. Remember, even though we've so far dealt with only cases where we have one common term, it is possible to have more than one common term. But in this case, in each case, we still have a common, just like one common term. So like, no, here we have actually two common terms in this group. Can you see the two common terms? Or factors, sorry, two common factors. It is common factor, not two common terms. It's possible to have two common terms, two common factors. Sorry, why the confusion? Two common factors when you want to factorize. So like in this case, we have 3mx minus 6m. Are you able to see the two common factors? Yes, 3 and m. So in this case, we'll have plus 3m. Then in there, we remain with x. And then minus 2. So you see, what we said is we pair. The procedure is pair or group. Grouping here means putting in pairs. When you hear factorization by grouping, the groups are comprise two terms. So like we have these and these. And then after grouping, you look for a common term, factor, or factors, and then factorize. You introduce the bracket. So in the first case, the common factor is n. So we have n into x minus 2. In the second group, the common factors are 3 and m, which translates to 3m. Then we have into x minus 2. Now, if you use your eyes properly, you'll see now here we have n multiplied by x minus 2, and then plus 3m multiplied by x minus 2. So in this expression, we have a common factor again, and our common factor here is x minus 2. So finally, we come and write x minus 2 being the common factor, and then in the other bracket, we'll have n plus 3m. This is the factorized form of the original algebraic expression that we are given. Remember, nx minus 2n plus 3mx minus 3m. When factorized, it comes to this. Let's look at another example where we don't have common terms, and we do not have like terms. And we are asked to factorize. So for instance, you are given p squared. You have p squared minus pq plus 4p minus 4q. You are asked to factorize. Again, look at here. There's no common factor to all the terms, and there are also no like terms for us to put together and then factorize later. So in this case, again, this is a case that is ripe for factorization by grouping. And remember, we've said our grouping is putting in pairs. So like in this case, we have this. You can still reorganize these and carry out the factorization, and you will get the same result. In other words, what I mean, you can rearrange these terms and then group and factorize, and you'll get the same results. In this case, I'm going through it without rearranging. So here we'll have, after pairing or grouping, a common factor. In this case, we have p. Then in our bracket, we'll have p minus q. Now, in the next group, can see the common factor is 4. So we'll have 4, then P minus Q. Remember, I've written 4 without writing a plus or minus here prior to that. If you are keen so far, you'll realize when we reach this stage of factorization, the two brackets are the same. Look at the previous case. When we found x minus 2, in the other case, we also had x minus 2. Now here we have P minus Q after pairing, after grouping. Then we also have P minus Q. That's one secret that you should have, that the first bracket will always be the same as the second bracket. Now this is important, especially where there are negative and minus, and at times we may need to put a minus here or a plus so that the meaning of our algebraic expression is not lost. But in this case, we still have our plus here. Remember, whatever you do after factorization, when you expand, you should be able to get back to the original. The meaning should not change. Factorization should only lead to the change of appearance, but not change of meaning. So again, look here. You have the same brackets. So this is a common bracket, P minus Q. So you take it, the common one. And then the other bracket will have what you have out there. In this case, P plus 4. So this is the factorized form of our algebraic expression. Let's look at another case. Or can give you this to do as an assignment, and you can give us your answer in the comment section. Can you factorize this as an assignment, which you can do, and you can share your results in the comment section? Could be asked to factorize 3RT, that is 3RT plus 2T plus 3RW plus 2W. I repeat, 3RT plus 2T plus 3RW plus 2W. Can you try that for your exercise and many other cases that you may encounter? Please do this and share it in the comment section, your results. And if there are any other questions, you may still share the comment section, and I'll be very glad to respond to it. Have a nice time. You press that like button and the subscribe button if you haven't. Good time and take care. Bye bye.